This is Nataliia Stulova presenting the paper titled Towards Detecting Inconsistent Comments in Java Source Code Automatically. This is joint work performed by Nierstrasz and myself at University of Bern, Switzerland, by Arianna Blasi at University of Lugano, Switzerland, and by Alessandra Gorla at India Software Institute, Spain. In our work, we target the problem of commits introducing inconsistencies between source code and their respective comments. Here in this slide, I have an example of ggraph-t code snippet. ggraph-t is a public open source Java library for graph manipulation. And I would like to draw your attention to three places highlighted in bright yellow on the slide. We'll start with the bottom one. It corresponds to the place where the arguments of a method titled assert and supported graph types are, and this method takes currently two arguments, graph J1 and graph J2. The reference to these arguments in the comment of the method is in two places. The first one is the natural language free text part with the phrase one of the graphs in the first sentence. The second place is in the comment body where the add tags are, so we see the add param graph1 and add param graph2. So sometime in March 2006, a commit happens that, among other changes, changes the method signature. So now we have only one input argument, graph G. However, none of the changes in the commit touched the comment, so the comment and code have diverged. Sometime later, in November 2013, 7.5 years later, developers fixed the inconsistency with code and the comment, but only partially. While we see that add param G now matches the method signature, the old phrase one of the graphs is still present in the first sentence of the comment, and it still refers to the plural graphs, implying more than one input argument. So the inconsistency is still there. Our work presents an approach for detecting inconsistent comments on change with natural language processing, and here you can see a schematic illustration of a tool architecture that's called UpDoc that does precisely this. So how it works? It takes two Java source files before and after the changes happened and parses them into an intermediate representation that is later processed by two tool components, mapper and change extractor. The mapper component has two tasks. First, it creates natural language representations of the code snippet and its comment, and it relays the two representations based on a similarity measure. So far, we have implemented cosine similarity and word movers distance similarity. Change extractor component creates an AST-based diff, which has the advantage of having clear code snippet scopes. This information is combined in the change analyzer component that emits a report on consistency between the code and the comment after the change. Later, this report is also taken as input by the fixed advisor component that complements the report by emitting fixed suggestions and notifying the programmer if the comment needs more changes and where. The core part of our technique and the tool is the code comment mapping. If you remember from the previous slide, it's done in two steps. In the first one, we extract natural language cues from both code and the comments and store them as bag of words. In step two, we measure similarity between the two bags of words, and a mapping link is added if the similarity between the two bags of words is high enough. Here on the slide, I have three bags of words. One corresponds to the first sentence of the comment from the example that we have seen earlier, and two other bags of words correspond to the source code, to the method signature part of the snippet before and after the change respectively. And you can see that when we measure similarity with the word Morse distance, we observe similarity decrease in the between the comment and the source code version after the change, which gives us a hint that something happened in the code that made the comment reflect the meaning of this functionality less precisely than it was before the change. So we performed a preliminary evaluation of the mapping accuracy of our tool. We have taken data from the public dataset of inconsistent documentation fixes that was presented 1 year ago at ICPC 2019, and it was produced by the Reveal group from University of Lugano. we take the first 50 commits of one parts of this dataset and filter out commits with fixes that our tool updog does not detect yet. In the bar chart on the right, you can see what has been filtered out. So basically, we filtered commit that only contained fixes that did not include changes in comments, that include changes in class level comments, that include changes in line comments, and we ended up with 20 commits that had 67 fixes in method level comments. Our research hypothesis for the experiment was that our tool updog would report higher similarity scores in the mapping for the fixed version. We obtained quite encouraging results. Among 67 fixes, 50 had similarity scores improved as expected. For 10, we observed 0 changes in the similarity because those fixes were mostly formatting in white space. And for 7 fixes, we have observed unexpected decreases in similarity scores, yet after manual inspection, all of them were figured out as cases not properly supported by our tool yet. So our hypothesis was confirmed. With this, I would like to end the short presentation of our paper titled Towards Detecting Inconsistent Comments in Java Source Code Automatically, in which I have shown you an example of inconsistencies that we are targeting. I've presented you the architecture of the tool that implements our NLP-based technique and the results of preliminary evaluation. We would absolutely love to talk about our research more with you. While our work is of high practical interest in itself, it can also be used in other software engineering tasks. For instance, there are many approaches for automatic comment generation, yet can we improve them with our technique to capture implementation faults earlier? Also, machine learning is used more and more in software engineering tasks, yet it is an alternative or more of a complement to our approach. What do you think? Let us know. Thank you for your attention.